Data types of variables in regression. One important thing to remember is that the data types that we are going to add in the regression are very important to be in the correct way. So the regular linear regression, we have to use a numeric, or even better, it's continuous, so decimal kind of variable for the dependent variable. So this over here in the regular regression that we're talking about now, linear regression, linear model, OLS, the dependent variable has to be decimal continuous. So the values can be decimal and not just integer. Now we can work with integers, so count data 1, 2, 3, 4, 5, if the numbers are can go pretty high and it's not, they don't have to be limited or truncated. But the best is to have continuous decimal. Either way, this has to be numeric. Okay, the dependent variable has to be numeric. So that's something you need to remember. Now, the independent variables, actually, they can be numeric or categorical. So for example, we have verified income here. We see that this is a categorical variable, and there's 3 categories. And also bankruptcy is also categorical. Remember, even though it's 0 and 1, we use this as, this is a categorical variable. So this is a factor in R. It's called a factor. It's categories. It's not continuous. Definitely not continuous, and it's not really integer. Although we kind of use it as an integer in the regression model. Also, some are a little bit more ambiguous. For example, term. Term is the term of the loan, and these are referred to months. And some loans are 36, some loans are 60. But this number is also a little bit artificial since it's definitely not continuous. You know, there's no loan that has a term of 36.54 months. It's either 36 or 60 or 90 and so on. So this is almost a categorical variable, and we deal with this in more advanced regression classes, but let's just serve it to note here. And you can kind of change this to a category, as we're going to talk about in a second. So for example, you can have a new variable that is called 60-month loan. 60-month loan, and that will become binary. It's either, if it's a 60-month, it's 1. If it's not, it's a 0. But either way, remember this, in regular OLS linear regression, the dependent variable has to be numeric, and the other variables can be categorical or numeric. So to interpret the predictors, if you have a numeric variable. Now, bankruptcy in this data set is actually binary. It's not numeric, but let's assume it is numeric in terms of integer. So a person can have 1 bankruptcy, or 2, or 3, or 4, or 5, or 6, or 7, or 15, or 39. So once we get the data, we load it into the model, and the model gets built from the data, and we get these estimate values here of the coefficients. And so how do we interpret these numbers here, especially the coefficient estimate? Well, as we said before, so this means that every unit increase of bankruptcy increases the interest rate by 0.74 points. And in this case, because the measure is in percentage, it's really 0.74 percentage points. And also we need to remember this is on average and assuming everything else equal. Assuming if we have other variables, they're all equal. And that's an advantage of the regression model because it controls for the other factors. So on average, assuming everything else equals, every unit increase of bankruptcy increases the interest rate by 0.74. So this interpretation is very important to remember, and keep thinking about this, write this down, and memorize how to interpret the coefficient and its impact on the outcome variable. Now, interpreting the categorical predictors is actually kind of similar way. So assume bankruptcy is binary, so it's 1 or 0 or yes or no. And we have to work actually with all the categorical variables that we're going to work with. They are going to be binary. So how do we interpret it? Well, we kind of interpret it the same way except that we changed it slightly. We changed the explanation slightly. So in this case here, assuming that bankruptcy is binary, and we're using this as a predictor of interest rate, so what happens is, so this is the result, how the results are going to show sort of in the R. This is a little bit more cleaned up. This is from the textbook. So here's the estimate. So this is the coefficient, and we have and this is the intercept, the alpha, and this is the predictor. Now notice that we don't see the interest rate, but it's not here, but we don't kind of need it. You know that from the model you built that that's what the outcome variable was. So so how do we interpret this? Well, this way. Those that have had bankruptcy have an interest rate that is 0.74 percentage points higher compared to those without a bankruptcy. Once again, on average, and assuming everything else equal. In other words, a person who has a bankruptcy increases their interest rate by 0.74 points compared to those without a bankruptcy. So it's very important to remember that this is compared to those without a bankruptcy. So it's kind of almost like the other one, if you increase the bankruptcy by 1 unit, meaning if you have bankruptcy rather than not, then you increase your interest rate by 0.74. Now, I'm going to stop here and actually discuss the categorical predictors in another video because it starts getting a little bit complex. So see you next time.